In this video, we're going to go ahead and finish out one of the last problems that we'll do in terms of your guys' formula sheet. And we're going to be talking about power received. That is equal to the power total times the gain over 4 pi r squared. Obviously, a lot of this is going to look familiar because everything just kind of builds on each other. And on your formula sheet, this is one of the last formulas that you guys do. And you'll kind of notice each time we just add one more thing on. And in this case, the thing that we're adding on is the effective aperture. And what that is the antenna's ability to actually capture the RF energy. So if we kind of cover this up, you'll recognize this as the power density at the antenna. And then the power received is going to be dependent on this factor, how well the antenna actually captures the RF energy. Let's go ahead and get some givens here. We have a range of 143 kilometers, a power peak 51 kW, a power factor, and that'll make it nice and easy when we go ahead and do the gain. Power factor of 12,589.3. A radar cross section of 4.3 meters squared. Pulse width PRT okay. Sorry, getting a little off the camera there. And lastly, we have an effective aperture of 22 meters squared. As always, the first thing we're going to solve for is the power total, and that's going to be our peak power of 51 kW multiplied by the duty cycle. Well, as we know, the duty cycle is going to be, you can figure out a few different ways, but in our case, we're given a PRT and a pulse width. So let's go ahead and figure out the duty cycle by doing our our pulse width divided by the PRT. So we'll say duty cycle is 2.1 microseconds over 3.448 milliseconds. So go ahead and get our power total on the calculator here. We're going to do 51 E3 times, and I can put this in parentheses, 2.1 micro divided by 3.448 milli. So our power total is 31.06 watts. And I can write that down here as the start of my setup for the equation. Times the gain, which is a power factor, and that's already given to us, so that kind of eliminates that step. 12,589.3 over 4 pi. Our range is already in kilometers, so 143K squared. Let's go ahead and figure this part out. We'll enter it into the calculator here. I'm going to do it in two parts. We'll do an A and a B. Just keeps things a little bit more organized. I'll start with the bottom. 4 times pi. You can see this on the calculator, sorry. 4 times pi times, parentheses, 143K squared. I'll store that as my B. I'll do the top, 31.06 times 12,589.3 equals, store that as my B, or excuse me, my A. And now I'll go A divided by B And we get, for this first part of the equation, 1.52 micro. And I'm going to just label this. I'm going to label it as C because we're going to come back to it in the equation. So this whole part will be C. And I'm going to go ahead and store that in my calculator as C. Store function is incredibly handy. Now let's focus on the next part of the equation, which is going to be our 4.3 meters squared over that same 4 pi r squared. And here's why storing stuff in the calculator makes it easy. We already stored that 4 pi r squared as variable b. So all I'm going to do is take 4.3 divided by, I'll recall b. And we have the second part of our equation. So let's go ahead. I'm going to label that as d here. And I will store that as d. So in the end, so far, we're going to have C times D times this last number here, which is the effective aperture. So this is telling us how efficient our antenna is able to capture RF energy, and that's 22 meters squared. So literally all we're going to do is recall C times it by D times by 22. And what we get is 560.18 times 10 to the negative 18. And if you got to refer back to your engineering notation sheet, that's fine. And that's going to be attawatts. So a watts. And this is just power received, so it's not a power density, it's not power over area. So this is actually our final answer. Now just real quick, this kind of, it goes like the before equation. We can actually combine these things to make it a little bit simpler for us. I'm going to show you what it looks like combined, but we're not going to go ahead and we're not going to enter it on the calculator. So we'll say power received is equal to power total times the gain times the radar cross-section times the effective aperture over, and this is where we combine these like terms. So 16 pi squared r to the fourth. And if you wanted to do this in your calculator, the way that I would do it the most efficiently is save this as an A, the top part is an A, save this bottom part as a B. Do those separately instead of trying to do this all in one run. You'll have better luck at it. But we'd get the same answer. If we did the A divided by the B, then we would get the same answer, 560.18 attawatts.